Hi, welcome to the Language Insights. So in this episode, we're going to solve an interesting, not so quite interesting, MEXor MIXup in contest, I think 1557 of Codeforces. Actually, it's quite interesting that we're going to explore the property of XOR. So I think this episode is good, not for the problem, but for the properties of XOR. So let's begin. Alice gave Bob two integers, and it's quite interesting, A and B. Being curious boy, Bob wrote down an array of non-negative integers. This is 0, 1, 2, 3, etc. with max value of all elements equal to A. So max will be A, and so XOR will be B. What's the shortest possible length of the array Bob wrote? And I hope you read calmly the problem. The link is in the description, as well as the solution in the GitHub. So recall that the max, the minimum excluded of an array, is the minimum negative integer that doesn't belong to the array. And we'll see that also, and the XOR is the bitwise XOR of all elements. And I suggest you practice, for example, trying to do with small numbers as 2. This is 1, 0 with 3, for example, which is 1, 1. And you're going to get a result, right? You're going to get something with XOR. Bitwise XOR is another word for the digits are different or not. So this is another word. So the description of the test case, okay. The only line of each test case contains 2 integers. So let's start our coding here. Actually, losing more time. So we just have to read A and B, which are 2 integers, the max and the XOR. And the problem asks us to do something. Actually, they give some 5 tests, right? And what it asks us to do is, for example, given max equals to 1 and an XOR equals 1, we have to get the minimum array that has this XOR. And actually, with this max, we have 0 and we don't have 1. If we had, for example, 2, we wouldn't need to have in our array 0, 1. And if it was 3, it would be 0, 1, 2. This is 0 till max minus 1. So our array has to have these max elements from 0 to max minus 1. But is that enough for our array? It seems not for these examples here. So let's try to understand better this problem. So, for example, if we had this little array here, the max is clearly, in this case, max is 4, because we know by the definition. And the XOR, we begin the first interesting property. The XOR of 4 consecutive numbers is 0. In this case here, I said that the sum, when we have 4 consecutive numbers, right, from 0 to 3, for example, the XOR is 0, but it's not all consecutive that will have 4, that will have 0 as the XOR. For example, 1 to 4 is not, the XOR is not 0. So, but for the purposes of this problem, we can consider sequences of 4 and 4 numbers beginning with modulo 0 here in this case. So we understood the basic ideas. I suggest you read the problem better to understand. But we know that if it begins with this, we just have to return. So let's create a variable called age that will have the XOR. So actually, we just do the following. For example, and we have to compare with the initial XOR, which is B, given a max, which is the minimum excluded, equals to A. So we have to first do the following. if we concluded that the first case is actually when it's 0. So when the first element, we're considering A here, so we're going to point, for example, A to the first element, and we do the following. And naturally, as we're considering the last element, we have to make an attribution like this for the last element. In this case, so if H modulo, for example, 4, because it's going to repeat the zeros every 4 elements, beginning with 0 here till 3, 4 to 7, so on, we verify if it's 0. If this is 0, we will have just to return the numbers. So our value is going to just be H in this case. So let's put something to receive this value. So let's put, for example, R to be this number. So R is going to be H. Else. So it's very interesting that we have this property and we can apply very good and we know that it's just commutative also. It doesn't matter the order in which you put the XOR. It's also associative. It's like a multiplication. Very, very simple. So, for example, just to be more clear, if we have two numbers, these ones, for example, and we apply this property, we're going to compare bit by bit, for example, this with this, and also this with this. So the first one, if they are different, right? In this case, yes, so we're going to have 1. If they are equal, we have 0. So basically checks if it's different, right? The XOR property. So else, if we have this number here, which is just equals to 1, it's in this case here, how much it's going to return? Actually, it's going to return 1, because 1 XOR 0 is just 1. And we can see that, in general, this works fine. If we test by our experience, we can see that it's going to work fine for 4 to 7. It's going to repeat this pattern, so it's really good to also try examples. If we do that with, if we try that with 2, in this case, XOR 2, in this case, it's going to be 3. So it's going to be the last element, which was H plus 1. Else. Else, we're just going to have, it's actually 0, because 3 with 3 is just 0. In any other case, it's going to be 0. So let's just put here, right? Let's just put here. So R equals 0. And, right, so we have to see more things. For example, we cannot, we have to check another thing. So if our result was as desired, this is if R equals our initial B, then what we're going to have is something where we don't just have to do anything. So we just have to go to the else. Actually, if it's different, we can try to append another number. This is, for example, if we have A XOR B, we just need to put A, because we have the property that if we append A, this is just going to be B, right? But that's not, in this case here, we have to do something, but we have to append 2 numbers. Why do we? Because we cannot append A, because A is excluded, as we said. So we have to append 2 numbers. So in this case, else if, sorry, oh, that's strange. We have to do the following. If, so now we have to check the following. If we can, if you can do that, right? What we have to do here. Actually, we have to append 2 numbers. So let's put like here the minimum elements that we have to append. So actually min begins with A, as in the beginning, 0 till A minus 1. A minus 1, which is H. So actually what we're going to do here, we just have to put min receives min plus 2, right? Or plus equals true. Actually, we can do, and else we have to append just one number actually. So this is quite right. And we have just to print our min. So it's going to be just like this. So let's copy the code and go to another window. So just running our code, for example, in this site here, and just copying our code, and we just come here and just paste, and we just press enter. So we're going to have just our sequence 3, 2, 3, 3. So I hope you had a great episode. So see you for another language insight, right? And also, I hope you develop much your creativity, because it's a fundamental skill nowadays for you to use your tools to build something new, and not just the things that are common and common sense for everyone to do. So that's what I hope that you have learned today in this problem.